Today we're going to be talking about solving systems with substitution part 3. So we're going to review these 4 problems with simplifying each of the expressions. We have 5 times the quantity x plus 2. When it's written like this, that indicates that we are taking 5 times x and 5 times 2. You can write it like this and simplify it to 5x plus 10. For letter B, 3 times the quantity 4x minus 7. There's subtraction, so I'm going to add and make it into a negative. Then I'm going to distribute a 3 to both terms. 3 times 4x becomes 12x, plus 3 times negative 7 is negative 21. You'll notice that this time I didn't show the multiplication as I did in the previous problem that I'm highlighting right now. If you would prefer to show that work, you can, but that's not an expectation. We do want to simplify the part where it says plus negative in part B, because that's not in simplest form. So 12x, well, a positive times a negative is a negative. So that becomes 12x minus 21 as my final answer. For letter C, there is subtraction, so I'm going to add and make it a negative 1. And then I'm going to distribute this negative 2 to both terms. Negative 2 times 5x becomes a negative 10x, plus negative 2 times negative 1 is a positive 2. So negative 10x plus 2 is my final answer. Letter D, negative times quantity 3x minus 4. Well, there's subtraction, so I'm going to add and make it a negative 1. And there's a negative out in front, but I'm actually going to put an imaginary 1 in between the parenthesis and the negative, so that becomes a negative 1. So I'm going to distribute a negative 1 to the 3x and to the negative 4. Negative 1 times 3x is negative 3x, plus negative 1 times negative 4 is 4. My final answer is negative 3x plus 4. So each of these systems requires you to use the distributive property after you make your substitution. So for number 1, we want to identify a variable that has already been isolated, or we might have to isolate one. If you notice in the first equation, our x is already by itself. So our x represents y plus 1. So I'm going to take the y plus 1, and I'm going to substitute in for the x in my second equation. So this becomes 2 times the quantity y plus 1 plus y equals 8. You'll notice I did y plus 1 in blue to indicate that I replaced my x value in the second equation with what it represented in the first. From here, I now need to go and I need to distribute my 2 to the y and 2 to the 1, which is what we were just reviewing. So this becomes 2y plus 2 times 1 is 2. Then I bring down the plus 1 equals 8. And I'm going to combine my like terms. 2y plus y becomes 3y plus 2 equals 8. I'm going to extend my equal sign. I'm going to subtract 2 from both sides. 3y equals 6. Divide both sides by 3. My answer becomes y equals 2. So I'm going to take that, y equals 2, and I'm going to plug it into one of my equations. Up to you on which one you're going to use. I'm going to choose the first one because it seems like it would be less work. So x equals 2 plus 1. X equals 3. So that means that my answer is 3, 2 for my ordered pair. Number 2, we have 3x plus y equals 8 and x equals 1 minus 2y. We have a variable that's already been isolated, which is the x in the second equation. That is represented by 1 minus 2y. So I'm going to take this 1 minus 2y and I'm going to plug it in for my x in the first equation. So this becomes 3 times the quantity, 1 minus 2y, plus y equals 8. Then I'm going to distribute the 3. But before I do that, there's subtraction between the 1 and the 2y, so I'm going to change it to adding a negative. Now I'm going to distribute this 3 to the 1 and to the negative 2y. 3 times 1 is 3, plus 3 times negative 2y is negative 6y, plus y equals 8. I want to combine my like terms of negative 6y and y. It becomes negative 5y. I'm going to bring down the 5 plus negative, I'm going to bring down the 3 plus. So 3 plus negative 5y equals 8. Well, just for spacing purposes, I'm going to move my work over to the right. 3 plus negative 5y equals 8. I'm going to extend my equal sign. Subtracting 3 from both sides, I have negative 5y equals 5. Dividing both sides by negative 5, y equals negative 1. Now I'm going to take the y equals negative 1 and I'm going to plug it into one of the equations. This time I'll do the first one, 3x plus y equals 8. You could plug it into the second equation, whichever one you prefer. I'm plugging in y equals negative 1. 3x plus negative 1 equals 8. Sending my equal sign, I'm going to add 1 to both sides. 3x equals 9. Dividing both sides by 3, I get x equals 3. So my x value is 3, my y value is negative 1. That makes my ordered pair 3, negative 1. Number 3. Our equations are 3x minus y equals 7 and y equals x plus 3. Well, the second equation is already isolated for our y. So I'm going to take my x plus 3 and I'm going to plug it into my y for the first equation. So 3x minus x plus 3 equals 7. Well, there's subtraction, so I'm going to add the opposite. And, well, having a negative there, I'm going to put an imaginary 1. That indicates that I have a 1 right there. I'm actually going to distribute a negative 1, both terms inside of my parentheses. So this becomes 3x plus negative 1 times x is a negative 1x, plus negative 1 times 3 is negative 3. That equals 7. I'm going to combine my like terms. 3x plus negative 1x is 2x, plus negative 3 equals 7. I'm going to extend my equal sign and combine my like terms on each side. So I'm going to add 3 to both sides. 2x equals 10. Divide both sides by 2. I get x equals 5. Now I need to solve for my y. I'll use my second equation this time. Y equals x plus 3. And I know that x equals 5 because I just solved that. So this becomes y equals 5 plus 3. So y equals 8. So my x value is 5, my y value is 8. So therefore, my ordered pair is 5, 8.